All right, let's talk about tangent lines a little bit. And the problem that we are given is one that says find the value of k such that the line is tangent to the graph of the function. So we have this. We have some function that is, let's just kind of get a visual for it. This is a parabola that is upside down, so it's kind of a frowny face. And it has some vertical shift, and we don't know about that vertical shift. We don't know where exactly it is. And then there is a line that is tangent to that, so y equals negative 2x minus 2. So there's some parabola and a line that is tangent to it. And we want to know the k value that we would have on this function that would make that a true tangent line. So let's just kind of go with what we know. And they said tangent line, so I'm just going to go off on a, well, tangent here. Haha. And write this. Do I have to write it? No, but it's going to come in handy. Now, I know you might be saying, well, we already have the tangent line. I hear you. I hear you. Trust me on this one, okay? Just trust me. When you're older, you'll understand. About 2 minutes older. Okay, let's start by figuring out the x value and the corresponding y value and the m value. Those are the things we don't know, right? So if I was to fill in everything I know, then I would just kind of be stuck here, right? So we really know very little to start off with. Well, to be honest, we actually do know something. And what we do know is, here it is, check it out. Our slope is negative 2. So we could just go ahead and put a negative 2 here. Now, eventually, we're going to get some equation here that we can beat into submission, supposedly, to look like this. And then when this matches with this will have a k in it. That one won't. We'll solve them. Right? Trust me. I know where I'm going with this. When you're older, you'll understand. Okay, let's find the derivative. Why are we finding the derivative? Well, because I want to find the derivative, because it's fun. The derivative, with this purple pen that's giving me so much trouble. There we go. The derivative is, let's see, negative 1x. Okay, well, the derivative is negative 1x, and the derivative at some specific value is equal to negative 2. So this is equal to negative 2, which really means that specific x value is positive 2. If you didn't catch what was just thrown at you, let me throw it again. We know the slope is negative 2. We know derivative is equal to slope. Set the derivative equal to slope. And we now know the x value that we're dealing with, and there it is. Okay, well, we don't know the y value that goes along with it, but we're about to find out what it is. And the y value is what we get if we plugged our x value in here. So let's figure it out. Come on, purple pen, let's go. F of 2 equals negative 1/2 2 squared plus k. And that is going to equal, let's see, that's 4 times negative 2. That'd be negative 2 plus k. So we have y minus the y value, and the y value is negative 2 plus k. Well, that doesn't look too neat. That's okay. It's not supposed to, because if we keep working on this, eventually it'll look like that. So let's make it do that, okay? So y plus 2 minus k equals negative 2x plus 4. So y equals negative 2x. Let's see, we'd subtract 2, and that would give us 2, and then we'd add k. Okay, wonderful, wonderful. Well, where are we going with this? I'm glad you asked. I'm very glad you asked. Because what we are going to do is take this and set it equal to that. Well, y equals this is the tangent line. Well, we also have the tangent line here. So we know that the tangent line they gave us is equal to the tangent line that we came up with. The tangent line they gave us is equal to the tangent line that we came up with. And the tangent line we came up with had a k in it. So this is our opportunity to find out what k is. That's what they wanted anyway. So minus 2x on both sides. It's going to cancel if we added 2x. We will move this 2 over. We have negative 4 is equal to k. Yay, we found it. Okay, well, the whole reason I'm doing this video on the computer is because I want to show you a visual of what this would look like. It's just really neat. So here we go. Let's let me cover the work. Let me go to Desmos and type this in, and you'll see what I mean. So let's do this. There we go. There's Desmos. So f of x equals negative 1/2 x squared plus k. And they're asking, what's k? And so we have this option to slide this around. y equals negative 2x minus 2. So what I want to do is find the k value to where the red parabola is tangent to the green line. And let's slide up because I think it's going to happen down here somewhere. Obviously, that's going the wrong direction. And we are going to go and go and go. And we're super close. And there it is right there. It is at k equals negative 4, which we found on paper, right? We know that it's k equals negative 4. But here we've demonstrated, of course, it happens at the point x equals 2, comma, negative 6. We knew that it happened at x equals 2 based on what we found on paper. But this gives us a visual for what's really going on. Just wanted to demonstrate that for you. Kind of neat, isn't it? I think so too.